Hello there guys, welcome back to another epic inexorable maths video. We have another t-formulae or tangent half angle formulae video coming right up. So as always, there's the t-formulae. Just as a recap, the t-formulae are used to turn trigonometric equations into algebraic equations so that they can more easily be solved, and then you can put them back into trigonometric equations at the very end. So let's just go straight into this because this is the third video, link in the description to the previous two videos and the playlist. This is the third video that I've done on t-formulae. At this point, we can jump straight in. We want to solve the equation 5 sine 2 theta plus 12 cos theta equals minus 12. Could be pretty difficult without the t-formulae, but luckily we have them. So first of all, the one thing here that's different is we have a sine of 2 theta, not theta. So what do? Well, we can just use the double angle formulae. So we can rewrite this as 5 times 2 sine theta cos theta, because sine of 2 theta is 2 sine theta cos theta. And then we have plus 12 cos theta still equals minus 12. Okay. Then let's use the t-formulae. So 5 times 2 is 10, and then sine of theta is 2t over 1 plus t squared. Cos of theta is 1 minus t squared over 1 plus t squared. And then we have another one of those, so 1 minus t squared over 1 plus t squared equals minus 12. Okay, and what can we do here? Well, we can try and expand some stuff out. Maybe I'm going to times both sides of the equation actually by 1 plus t squared twice, okay? So I'm going to get 10 times 2t times 1 minus t squared plus 12 times 1 plus t squared times 1 minus t squared equals minus 12 times 1 plus t squared squared. Okay, just so you can look at what I've done there. Basically, all I have done is I've multiplied both sides of the equation by 1 plus t squared and then done it again, okay? And the reason for that is just because it gets rid of all of the fractions, which is pretty good. Okay, then there's not really a lot we can do here. There's no like terms for anything. We're gonna have to expand the whole thing out, but luckily it's not too bad. So 10 times 2t is 20t, and then times that by 1, so we have 20t, and then times by minus t squared, that's minus 20t to the power of 3, okay? And then this here is the difference of two squares. This becomes 1 minus t to the 4, so plus 12 minus 12t to the 4 equals, and then I will just do this in 2 steps. 1 plus t squared squared would be 1 plus 2t squared plus t to the 4. And then timesing all of that by minus 12, we would get, let's just rewrite the whole thing because maybe, no, there's no like terms on the left. So I'm just going to rewrite the left-hand side. Okay. So this one obviously has quite a lot of just faffing about with algebra, but that's okay. Times everything by minus 12. We have this. This is a quartic equation. It might be a bit gross, but hopefully we can do something with it. So first of all, we are slightly saved. It's not quite a quartic equation because both sides have a minus 12t to the 4. So we can add 12t to the 4 to both sides to cancel them out. We're not quite as lucky with the t cubeds because they're still there. Let's move everything onto the left-hand side. So we have minus 20t cubed. Okay, what else do we have? We have some t squared action, so plus 24t squared. Okay, what else do we have? We have plus 20t. And then we have a plus 12 and there's a minus 12, so we can add 12 to both sides. So plus 24 equals 0. Okay, what can we do here? Well, we could divide everything by, what could we do? We could divide everything by 4. That would be pretty good. So that gives us minus 5t cubed plus positive 6t squared plus 5t plus 6 equals 0. Now, at this point, and one more thing I'm going to do, by the way, guys, is I'm going to times everything by minus 1 just to get rid of the negative on that. So that's a minus, that becomes a minus, or that becomes a, what actually was that? it was 5t, so that is right, yeah, that's right. And then that becomes a minus as well, okay? And then the tricky thing with this is it's a cubic, so we really can't do an awful lot with it. However, if we notice one thing, because sometimes this does work, if we notice that actually when we plug the number 2 into this for t, we actually do get 0. I'm just going to quickly show you that. Plugging 2 into this, we would get 5 times 2 cubed, which is 8, minus 6 times 2 squared, which is 4, minus 5 times 2, so minus just minus 10, and then minus 6. Okay, simplifying this, we have 40 minus 24 minus 10 minus 6, okay, which is 40 minus, this is 34, and then so minus 40, which is 0. Now you might say, okay, who cares? But if you know about the factor theorem, then we know that if t is a root of this, which we have just seen that it is, then t minus 2 is a factor, okay? And because it's a factor, we can use polynomial long division in order to simplify it and turn it into a factorized form, okay? So let's do that right now. I'm going to rub off some of the earlier stuff, and I'll be back with you guys in just a second. Okay guys, so we're going to now use polynomial long division in order to simplify this. We know that t minus 2 is a factor because we found that t was a root, and that's the factor theorem, okay? So everyone does polynomial long division a bit differently. So I'm just going to do it my way, and you can do it however you do it. Maybe you do it the same as me, actually, I don't know. But I'm just going to do it my own way. I'll do it my way. Okay, you guys did not come here for that. Don't you worry, I'm gonna stop myself. Anyway, we have this so far. Okay, cool. 4t minus 4t squared minus 8t, boom, 0, minus 5 minus 8, that's plus 3t, minus 6, 3 plus 3, minus 3, minus, that's t, minus 6, yes, good, 0, 0, no remainder, as expected. So now, basically the conclusion of this is that t minus 2 times 5t squared plus 4t plus 3 equals 0, okay? The original equation was 5t cubed minus 6t squared minus 5t minus 6 equals 0, but we factorized it and we found that this is actually the same as what we had a moment ago. If you don't believe me, expand that out and watch yourself get back to where we were. Okay, cool. Now this is really good because, well, it's a linear factor and it's a quadratic. So this is good, we can find the roots. One of the obvious roots is t equals 2. Okay, clearly we've already found it. If t is 2, we're happy. Now, thankfully for us, this is going to save us a few seconds, that quadratic doesn't have any other roots at all. Well, it doesn't have any real roots because, and we can see this very quickly by using the discriminant. Okay, so b squared minus 4ac. Okay, using the discriminant here, we have 16 minus 4 times 5 times 3, and without even doing the calculation, guys, this is clearly negative, which means there's no solutions. So we can just completely ignore that quadratic, and it tells us that the only real root was t equals 2. That means that tan of theta over 2 is equal to 2, and then we can just solve, and it's really easy from here. So that means that theta over 2 is equal to arctan of 2, and again we're in radians, so arctan of 2 gives us 1.107149 approximately, and then if we were to add pi to that, the thing is that we would be out of the interval, so it looks as though this is the only answer, okay? That's what it looks like. So if we double this, timesing by 2, we get 2.2143 roughly. And it appears that that's the only answer because we could have added pi to this, but if we added pi, we would have then ended up doubling it, and it would clearly be bigger than 2 pi because 2 pi plus a positive number would be bigger than 2 pi, obviously. So it looks like this is the only answer, but there's one caveat. As I've mentioned in the past 2 videos, the t-formulae will not do one thing. It has one pitfall, and that is if an odd multiple of pi is an answer, you won't get it as an answer, okay? Now, that means that we have to check to see whether theta equals pi, because it's the only odd multiple of pi in the interval, is a solution. And the thing is, in this question, it turns out that it actually is, because sine of 2 pi is 0, so 5 times 0, okay, but cos of pi is minus 1, so we have 12 times minus 1. So pi is a solution. Very easy to miss this, but another answer is pi. But the t-formulae will not give us that because tan of theta over 2, tan of pi over 2, it's not defined, okay? So these are the 2 answers. Be very careful about those pi's. Okay guys, thank you so much for watching. As always, I highly appreciate it. It was a pretty tough question, but it was pretty fun. And I will see you in the next video. Cheers.